So here's a question. We were talking about having the the capacitor power factor correction on the load side of the disconnect. So we have our capacitor bank here, and we're going from there to our motor. Okay, so here's our cap bank. Here's our motor. Again, this is a scenario where this acts as a disconnect for the bank, and we don't have to have discharge resistors because they're going to discharge through the motor windings. So they want us to size the overloads in here, and so here's our overloads, and we want to see what size they need to be. Again, we got to use based off the correct current. So here's a question that says we have a 208 volt motor as an FLA of 28 amps at a 0.65 lag with a service factor of 1.15. The cap bank is on the load side of the and corrects the motor current to unity. Okay, so that's important to unity. What is the setting of the overload device? So basically what I do is I make a triangle, just like I have in RLCs the whole time as well too. A current triangle. So if I take this 28 amps on the hypotenuse, or on the total current if you will, then I'm going to put it on the power factor, and then I'm going to take my power factor and get my actual resistive current. So 28 times 0.65, and I get 18.2. So if they want the circuit to be corrected to unity, I could find this value. So basically then I'd be adding a capacitor, and I'd be left with a straight line at the end, because these are going to cancel out these. So really I can just carry this over like I normally would, and if these were canceled out, these inductive VARs were canceled out by these capacitive VARs, then I'd have no reactive portion here. So this is the new current. So 18.2 would be my actual current that I could size my overloads from now. This would be the corrected current. So my motor had an FLA of 28 amps. After I correct, I have right at this point, I have 18.2 amps. So obviously a significant difference there. So we can take this value now and size our overloads. So if it says it's 1.15 service factor, if we go to our code rule for motors, it's 125% times 18.2, so times 1.25, and I get 22.75 amps. So that is what the overloads would be set at. Okay, so that's an example there. Just use your current triangles to find out those new values. If they wanted it to correct it to a 0.9, then you would carry over here, make a new triangle, and it would be at 0.9, but you'd still carry this 18.2 over, and then use that power factor to find out your new total current, and then you could find the reactive portion and see what size of cap bank you would need there. Again, that's power factor correction right there too, but we're using the power factor right now to help us decide the size of our overloads.